So here we go with the last section. This first question wants us to determine what the element is that has these four quantum numbers for the last electron in its filling order. So we know N equals 4 and L equals 1. So we know it's a 4p element. So 4p means it's going to be somewhere in this area right over here. 4p specifically in this row right here. Okay, so we know M is 0. Remember there are three orbitals. -1, 0, and 1 are the three values. And this positive 1/2 means it's spinning clockwise, like that. So that's the first electron in that orbital. So let's see if we can figure that out. So we got 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. We've already established it's going to be in 4p. So 1s, 2s, 2p has 3 orbitals, 3s, 3p has 3 orbitals, 4s, 3d has 5 orbitals. And that's the -1, that's a 0, that's a 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. We said it was a positive 1/2, which means it's the first one in that orbital. So that's 32 electrons, and we have to stop there. That's the one that's spinning clockwise. So element number 32 is germanium. The next one, the quantum numbers for the highest energy electron in aluminum. So aluminum is has 13 electrons. We know that right here. 1s2, 2s2, 2p6, 3s2, 3p1. We want to know the quantum numbers for that electron. So we know that N equals 3 because it's on the third floor. It's a p sublevel, so L equals 1 based on what we said in the earlier parts of this video. Then there are 3 orbitals in the p sublevel. That's the first one, -1, 0, 1. So the M value is going to be -1 because there's only one electron in the 3p, so it's going to go right there. And that's the first one in, so it's spinning clockwise. Complete p sublevel, including all orbitals. Remember the p's were the little dumbbell shape, so there's one of them. The second one is this one. What's the third one going to look like? So it'll be something like that. A 1s, a 2s, and a 3s. 1s, 2s, 3s. They just get bigger. Okay, now this last question, we want to know the orbital diagram for 10. 10 has 50 electrons. That's going to take a minute, so here we go. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Again, I know this so easy because it's 1s, 2s, 2p. I'm just going through the periodic table until I get to 10. Element 50. So 4p, then 5s, then 4d, and 5p. And 10 actually is in the second position in the 5p row, so I know it's going to end there. So put the orbitals in. All the s's get 1, all the p's get 3. S's get 1, d's get 5 orbitals. P's 3, S1, D's 5, and then the P 3. Okay, we're going to 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. All right, now the question says how many electrons have an M sub L value of 0? Well, there's 0. There's 0. That one would be -1, 0, and 1, so that's 0. This orbital is 0 because M is, if L equals 0, then M has to equal 0. This is 0. All these have M values of 0. So how many electrons is that? So you got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Because there's only one in this orbital where it has an M value of 0. So that was kind of quick on the last page, but we got through the whole test, and hopefully that helps you as you study.